Okay, here's number 1. The table shows the average lengths of the bones in a human leg. How much longer is the average femur than the average tibia? So we're wanting to know the difference in length between femur and tibia. So what does difference tell us to do? Subtract. So we're going to subtract the femur length from the tibia length. So the femur length is 19.88. And then we want to subtract the tibia length, which is 16.94. So when I subtract those, 8 minus 4 is 4. 8 and 9, I cannot subtract that, so I have to borrow. So borrow from the 9, it becomes an 8. 8 becomes 18. 18 minus 9 is 9. 8 minus 6 is 2. So number 1, you should get $2.94. So that's not money. It's 2.94 inches difference. Any questions on that one? How many tables are needed? So how did you solve this one? Somebody, anybody? Go ahead.
500 divided by 8.
500 seats, or the 500 people, divided by the 8 different tables. And what did you get when you divided that?
Yeah. 62.4.
62.4. Okay, let me do it real quick. I think you may be a little off. I think you're really close. I got 6 minus 48 is 2. Bring down the 0. 2 times minus 16. So right here, you got 4 left over. So is that where you got your 0.4 from? Okay. That's not how that works. That 4 would be the remainder. So if we said it had a remainder of 4, then that would be good. But what we normally do is we add a decimal and we add another 0 and bring it down. 8 goes into 40 how many times? 5. So then you subtract that 40 to get 0 left. Sorry, I about ran out of room there. But so instead of 62.4, it should have been 62.5. So do you think these people are really going to wheel out 62.5 chairs or 62.5 tables? Why not? Because you can't bring out half a table unless they cut one in half. But then the legs wouldn't work. So no, it's not going to happen. So how many tables are they going to put out?
62.
No. 63. They put out 62. There's going to be 4 people and nowhere to see it. You 4 people, y'all just go home. Okay? They'll put out 63 tables, so it'll get everybody that's supposed to be there. There'll be a few extra seats. Who cares? Right? It fits everybody. So how much did it cost Marlon to buy this?
$10.
$9.
Well, it didn't cost $10. He paid $10.
Yeah, that's all. I paid $10 when you got it.
Okay.
I didn't want to say
Oh, I got you. So how much did it cost? Well, how could we figure that out? 2 medium drinks? Well, how much is a medium drink?
$2.
$2.75. So how much did he pay there? He paid 2 times $2.75. And then he got a large popcorn. How much did that cost? $3.95. And so that's how much he paid. So if I add that together, that should be how much it cost. So when I add that, you get $9.45. He paid with $10. So how much change should he get?
55 cents.
Right. You should take $10 that he paid, subtract that $9.45 to get 55 cents worth of change. Okay, so now we're going to multiply 24 times 0.75. Here we go. We do 24 times 0.75. Can I multiply 5 times 4 is 20. I carry a 2. 5 times 2 is 10, plus 2 is 12, so it's 120.
Oh.
Now what? I have to bring down a placeholder 0. 7 times 4 is 28. Carry the 2. 7 times 2 is 14, plus 2 is 16. Like I told you before, right? I didn't mess up. I don't know what you're talking about. So, now I add these. 0 plus 0 is 0. 2 plus 8 is 10. Carry a 1. 1 plus 1 is 2. Plus 6 is 8. And 1. So now koalas sleep 1,800 hours in a day. No. So what has to happen? Remember when we read here, we have the same number of decimal places as our things that were being multiplied. So how many decimals did I have in my multiplication?
0.
Does 24 have any decimals? Does 0.75 have decimals? It does. It has 2 decimal places, which means my answer needs 2 decimal places. So I move the decimal 2 places, and that gives me 18.00 or 18 hours. So koalas sleep 18 out of the 24 hours in a day. So our focus on this problem, the multiplication is not too difficult. What I want to focus on is what we are expecting the answer to be. So before you do this problem and you look up there, about what do you think the answer should be?
3.
Why? Just because you feel like 3 is a good number?
Yes.
Okay, this number is really close to what?
1.
And this number is really close to what?
1.
So if you were multiplying 1 times 1, you would get... If you're multiplying 1 times 1, you get... Boy, we're going to have to work on multiplication facts. That is not good. 1 times 1 is 1. Yeah, but I heard 3, and I heard 0, and I heard...
I said 2, but I forgot that it was multiplied.
2. We're going to have to practice. Okay, so 1.3 times 0.9. We expect an answer to be around 1. So I'm going to multiply. 1.3 times 0.9. 3 times 9 is 27. Carry the 2. 9 times 1 is 9. 9 plus 2 is 11. So I have 117.
So on the second row, would you put a 0 right there?
Right here.
Yeah, no, under 7.
If I were to multiply again,
Yes.
yes.
Okay.
But we don't have to. I mean, if you put another placeholder 0, that's fine. But 0 times 3 is 0. 0 times 1 is 0. So when we're multiplying by that 0, it's not going to do us any good there.
1.17.
How did you know it was 1.17?
Because 3 and the 9.
There are 2 decimal places that are being multiplied. Therefore, I need 2 decimal places in my answer. So the decimal would go here, 1.17. Is that pretty close to 1?
Yeah.
Yeah, so it kind of makes sense, so I probably did my math correctly. Okay, it's just a way to kind of check before we get there. 0.054 times 1.6. So now again, let's check before we multiply. Let's see about what we think our answer should be. So 1.6 is kind of close to 2. This number is pretty close to...
1. No.
It's closer to another number than 1.
Freaking 0.
It's pretty close to 0, is it not? 0.05? That's like if you had 5 cents, okay? It's not much of anything. So when I multiply this, I expect a pretty small number, pretty close to well, we could be real specific. Like, do y'all see how I'm talking about this is almost a nickel? 0.05, so that's 5 cents. And then this is almost 2. So if you double a nickel, what are you going to get? That means you get 2 nickels. So you have 10 cents. So it's going to be a real small number, right? It's what we're expecting. So then let's do the multiplication and see if that is actually what happens. So I've got 0.054 times 1.6. Okay, 6 times 4 is 24. Carry a 2. 6 times 5 is 30. 30 plus 2 is 32. Now I go to the next digit, so I have to add a 0 for a placeholder. 1 times 4 is 4. 1 times 5 is 5. Now I add these together. 4 plus 0, 4. 2 plus 4, 6. 3 plus 5 is 8.
And then the decimal.
Okay, so 864, but I need to figure out how many decimal places I need. So how many do I need? Let's count them. I need 1,
Oh.
2, 3, 4. You see how that works? I have 4 numbers that are in a decimal place. So I need 4 numbers on the right side of my decimal. So right now the decimal's here at 4, so what do I have to do? I have to move it 4 times. 1, 2, 3, 4. Well, I don't have enough digits, so what do I have to do? Add zeros. So that means my answer here should be 0.0864. Okay, so this would be, if I think back to my numbers I was thinking of before, this is a little bit more than 8 cents, almost 9 cents, which is reasonable with what I was thinking, being a dime earlier. Okay, so that means I probably did my calculation correctly.